Why are there only three dimensions? Up, down, left, right, forward, back. That's it. That's all you get. You've probably heard the answer before. That's just how space is. Maybe you heard something about string theory. Extra dimensions curled up too small to see. That belief is not a little wrong, it's fundamentally wrong. Here's what nobody tells you. In 1917, a physicist named Paul Ehrenfest proved something terrifying. He proved that atoms cannot exist in 4 dimensions. Electrons wouldn't orbit. They'd spiral inward and crash, or fly off forever. No stable atoms, no molecules, no chemistry, no you. 3 dimensions isn't a random setting. It's the only number where light behaves, where gravity works, where matter holds together. The universe doesn't have 3 dimensions because it wanted to. It has 3 because that's the only number that balances the books. Change it to 2, light can't propagate cleanly. Change it to 4, planets can't orbit. Change it to 5, forget it, nothing survives. You're not living in 3 dimensions by accident. You're living in 3 dimensions because it's the only option that doesn't collapse. This isn't philosophy. This isn't speculation. This is physics doing its accounting. And by the end of this video, you'll understand exactly why the number 3 isn't arbitrary. It's inevitable. Let me show you. Do something for me right now. Hold your hand up. Any light source works. Lamp, window, phone flashlight. Look at your shadow on the wall. Simple, obvious. You've done this 1,000 times. But here's the part your physics teacher skipped. That shadow exists because light travels in straight lines through 3-dimensional space. Photons leave the source. Your hand blocks some. The rest hit the wall. Shadow forms. Beautiful. Now ask the question nobody asks. Why 3? Not what are the 3 dimensions. That's easy. Length, width, height. Boring. Why that number? Why not 2? Why not 4? Why not 7? You might think this is philosophy, some unanswerable cosmic mystery. Wrong. This has an answer, a precise, terrifying mathematical answer, and it starts with that shadow on your wall. See, your shadow has a specific shape, a specific edge. That edge exists because light intensity follows a rule, a brutal rule. Light spreads out. The farther it travels, the weaker it gets. In 3 dimensions, light follows something called the inverse square law. Double the distance, the intensity drops to 1/4. Triple the distance, 1/9. This isn't a suggestion, this is enforcement. And here's where it gets uncomfortable. That inverse square law, it only works because space has exactly 3 dimensions. In 2 dimensions, light would follow an inverse law, just inverse, not inverse square. Intensity drops slower. Shadows blur differently. Everything changes. In 4 dimensions, inverse cube. Light dies faster, much faster, too fast. Think about what just happened. The simple fact that your shadow has a crisp edge, that you can see it clearly on the wall, is proof that you live in exactly 3 spatial dimensions. Not approximately 3, exactly 3. Your shadow isn't just a shape, it's a receipt, a cosmic receipt, proving the dimensionality of the space you occupy. Hold that satisfying answer. It's about to break. Because shadows are cute, they're a party trick. The real question is deeper. What happens to gravity in different dimensions? What happens to atoms? What happens to the fundamental stability of matter itself? This is where the universe reveals its accounting. Strict, merciless, non-negotiable. The number 3 isn't written in the laws of physics. The number 3 is the law of physics. So far we've learned that light spreading through space obeys the inverse square law, that this law depends entirely on 3 dimensions, and that your shadow is physical proof of this constraint. But here's the thing. Shadows don't build universes. Gravity does. Atoms do. And when you apply this dimensional accounting to gravity and matter, everything you thought you understood about why space is this way collapses, and something far stranger takes its place. Gravity follows the same rule as light, inverse square law, spread through 3 dimensions. Double the distance, quarter the force. This isn't coincidence. This is geometry. Imagine you're standing in the center of a balloon. You blow outward. The surface of that balloon expands. In 3 dimensions, the surface area grows with the square of the radius. That's why it's inverse square. The force spreads across a surface. The surface grows as a square. The force per unit area drops as a square. Simple. Now here's the part nobody talks about. What if space had 4 dimensions? Then you're not blowing into a balloon. You're blowing into a hyperballoon, a 4D sphere. The surface grows as the cube of the radius, inverse cube law. Gravity would drop faster, much faster, way too fast. And that changes everything. Here's a thought experiment. Picture Earth orbiting the sun. In 3 dimensions, there's a sweet spot, a stable orbit. Earth falls toward the sun, but its sideways motion carries it around. Balance, stability, 1 billion years of consistency. Now switch to 4 dimensions. Inverse cube gravity. That sweet spot? Gone. The math is brutal. In 4 dimensions, stable orbits don't exist. Not hard to achieve. Not rare. Mathematically impossible. Any planet would either spiral into its star or fly off into the void. No exceptions. No workarounds. This isn't a theory. It's a constraint. The universe doesn't negotiate this. Let me say that again. In 4 spatial dimensions, planets cannot orbit stars. No stable solar systems. No rocky worlds. No place for life to evolve. Done. But wait, it gets worse. Zoom in. Forget planets. Forget stars. Look at an atom. An electron orbits a nucleus. Same game, same rule. Electromagnetism follows the same dimensional spreading. In 3 dimensions, inverse square, stable electron orbits, chemistry works. In 4 dimensions, inverse cube. Electrons can't hold stable orbits around nuclei. They spiral in, crash, annihilate, or they fly away, escape forever. Either way, no atoms. No atoms means no molecules. No molecules means no chemistry. No chemistry means no proteins, no water, no DNA, no you. And here's where your intuition lies to you. You might think, okay, 4 dimensions is bad. What about 2? Simpler, right? Wrong. 2 dimensions has its own nightmare. In 2D, waves don't propagate cleanly. Light doesn't travel in sharp beams. It smears. It echoes. Signals blur into noise. Communication becomes impossible. Vision becomes impossible. And gravity? In 2 dimensions, gravity doesn't drop with distance at all the same way. The mathematics of 2D gravity create logarithmic potentials, weird, unstable, hostile to structure. 2 dimensions, no complex life. 4 dimensions, no atoms. 5, 6, 7, each one worse. The universe keeps strict books, and the only number that balances, the only ledger that doesn't collapse into chaos or emptiness is 3. Exactly 3. Not a preference, not an accident, a counting. So far, we've learned that both light and gravity follow spreading rules determined by dimensionality. That 4 dimensions kills orbits and atoms. That 2 dimensions kills wave propagation. And that 3 is the only number that permits stable matter. But who figured this out? And why don't you know their name? The world is at war. Einstein just published General Relativity. Quantum mechanics is being born. And in the Netherlands, a physicist named Paul Ehrenfest asks a question nobody else dared to ask. Why 3? Not what are dimensions, not how do we measure space. Why this number? Ehrenfest wasn't famous like Einstein, wasn't flashy like Feynman. He was quiet, meticulous, the kind of physicist who noticed what others ignored. And he noticed something terrifying. Here's the part nobody tells you. Ehrenfest didn't just wonder about dimensions, he calculated them rigorously. He took the laws of physics and asked, what if we change the number? The answer broke everything. He proved that in 4 or more dimensions, there are no stable bound orbits. Not approximately none, 0. The mathematics forbid them. Electrons can't orbit nuclei. Planets can't orbit stars. Nothing holds together. He wrote it in a paper, published it, waited for the world to react. Silence. Almost nobody cared. Think about what just happened. A physicist proved that the number of dimensions isn't arbitrary. It's the only thing keeping atoms alive. And the scientific world shrugged. Why? Because in 1917, everyone assumed 3 dimensions was obvious, self-evident, not worth questioning. People say dimensions are just directions you can move, but that's just a label. Ehrenfest showed they're not directions. They're constraints, rules, the architecture of possibility itself. And here's where it gets even stranger. Ehrenfest's life didn't end well. He struggled with depression, felt overshadowed by Einstein, who was his close friend, watched the physics world race past him into quantum mechanics, a field he helped create but never felt at home in. In 1933, he took his own life. His dimensional paper? Almost forgotten. For decades. Then something changed. In the 1970s and 1980s, physicists started taking extra dimensions seriously. String theory, Kaluza-Klein theory, higher dimensional models. And suddenly Ehrenfest's question mattered again. Why 3 large dimensions? If string theory requires 10 or 11 dimensions, why do we only experience 3? Ehrenfest had already answered, 70 years earlier. Because 3 is the only number that permits stable structures. The others must be hidden, curled up, compactified, because if they were large, we wouldn't exist to observe them. The universe doesn't issue refunds. Ehrenfest's forgotten paper became the foundation for understanding why extra dimensions, if they exist, must be invisible. He asked the question that seemed too obvious to ask, and the answer reshaped our understanding of reality itself. Hold that thought, because Ehrenfest proved atoms need 3 dimensions. But can you feel it? Can you intuit it? Let's try something simpler, something you can picture. Imagine tying your shoes in 4 dimensions. Do this right now. Look at your shoes. Or any knot nearby, a charging cable, headphones. That knot holds because of 3 dimensions. Sounds ridiculous. Let me explain. A knot is a loop that passes through itself. In 3 dimensions, once you tie it, the rope can't escape without going back through the loop. The rope is trapped. Now imagine 4 dimensions. In 4D, there's an extra direction, a direction perpendicular to everything you can see. The rope doesn't need to go back through the loop. It can slide around it. Through the 4th dimension, every knot unties itself in 4 dimensions, automatically, instantly, without effort. This isn't a theory, it's a constraint. Knots cannot hold in 4D space. Now here's the twist. What holds an electron to a nucleus? What keeps atoms together? A kind of knot, not a literal rope, but a binding, a configuration where the electron is trapped in an energy well. It can't escape without extra energy. In 3 dimensions, that trap holds. In 4 dimensions, the electron has an escape route. Always, in every configuration, it slips out, like a knot untying itself. No stable atoms, no chemistry, no you. Beautiful. And here's where your intuition lies to you. You might think, okay, 4 dimensions is weird. What about fewer? 2 dimensions should be simpler. Try tying a knot in 2D. You can't. Lay a string on a table. Try to make a knot that holds without leaving the surface. Impossible. In 2 dimensions, strings can't cross over themselves. There's no over, only beside. No knots, no stable bindings, no complex structures. 2 dimensions? Too simple for structure. 4 dimensions? Too free for stability. 3 dimensions? The only number where knots hold, where things stay tied, where electrons stay bound. The universe keeps strict books. People say atoms are tiny solar systems, but that's just a label. They're knots. Energy configurations that can't untie, trapped by the geometry of exactly 3 dimensions. Not approximately 3, exactly. Think about what just happened. Your shoelace proves the dimensionality of space. The fact that it stays tied, that anything stays tied, is a cosmic receipt. 3 dimensions isn't a setting, it's the only option that allows binding. But thought experiments are fun. What about real technology? Something you use every day that would shatter in different dimensions. Your phone knows exactly where you are right now, and that only works in 3 dimensions. Open your phone, open maps. That blue dot showing your location, it's talking to satellites right now, 20,000 kilometers above your head, and it only works because of 3 dimensions. Here's how GPS actually functions. 4 satellites send signals. Each signal contains a timestamp. Your phone measures how long each signal took to arrive. Light speed times travel time equals distance. Now you know how far you are from 4 different points in space. In 3 dimensions, 4 distances give you exactly 1 location. Only 1 point in 3D space can be that specific distance from 4 known points. Exactly 1. This is called triangulation. Actually, with 4 points, it's trilateration. Same idea. And here's where it gets uncomfortable. What if space had 4 dimensions? 4 distances wouldn't be enough. In 4D space, the same 4 distances describe a whole curve of possible locations, an infinite set. Your phone couldn't pick 1. You'd need 5 satellites to narrow it down, maybe more. The math gets ugly fast. But that's not the worst part. Here's the part nobody tells you. GPS doesn't just rely on 3 spatial dimensions. It relies on light traveling predictably through those 3 dimensions. Inverse square spreading, clean wave propagation, signals arriving sharp and measurable. In 4 dimensions, light spreads faster, signals weaken quicker. The inverse cube law kills your signal strength before it reaches the ground. In 2 dimensions, signals smear, echoes pile up. Your phone can't distinguish the original signal from its reflections. 3 dimensions is the only configuration where satellite navigation works, period. Reality doesn't issue refunds. Every time you check your location, you're confirming the dimensionality of space. Your phone is performing a physics experiment, constantly, and it keeps returning the same answer, 3. People say GPS is just technology, but that's just a label. It's a dimensional audit, running billions of times per second, across every phone on Earth. Do this right now. Open your maps. Watch that blue dot. You're watching 3 dimensions prove themselves in real time. If space had 4 large dimensions, that dot wouldn't exist. The system collapses. The math fails. Navigation becomes impossible. But thought experiments and technology are still human scale. What about the cosmos? What happens when you push dimensional questions to the extreme? String theory says there are 10 dimensions. So where are the other 7? And why can't we see them? String theory requires 10 dimensions. Some versions say 11. You live in 3. Where are the others? This isn't a mystery. It's an answer hiding in plain sight. Here's the standard explanation. The extra dimensions are compactified, curled up so small you can't detect them. Smaller than atoms, smaller than protons, smaller than anything you've ever measured. People say extra dimensions are hidden, but that's just a label. They're not hidden. They're imprisoned. And here's why. Imagine a garden hose. From far away, it looks like a one-dimensional line, just length, no width. But get close. The hose has a surface. You can walk along it. You can also walk around it. One large dimension. One tiny curled dimension. Same idea with string theory. 3 large dimensions you move through. 6 or 7 curled dimensions too small to notice. But why small? Why must they be curled? This is where Ehrenfest's ghost returns. If those extra dimensions were large, if you could move through them like you move through length, width, and height, everything breaks. Light would leak. Gravity would spread into the extra dimensions, dilute itself, become impossibly weak at normal distances. The inverse square law would become inverse fourth power, inverse fifth, depending on how many dimensions opened up. Atoms collapse, orbits fail, chemistry dies, and that changes everything you thought you understood. The extra dimensions aren't small by accident. They're small because large extra dimensions are lethal. The universe keeps strict books. Any configuration with large extra dimensions doesn't produce stable matter. No stable matter means no stars, no planets, no life, no physicists writing string theory papers. Wild. The only universes that can contain observers are universes where extra dimensions stay compactified. This isn't a coincidence. It's a selection effect. We observe 3 large dimensions because 3 large dimensions is the only configuration that permits observers. Dangerous. This is called the anthropic constraint, and physicists hate it. It feels like cheating, like giving up on deeper explanation. But Ehrenfest math doesn't care about feelings. 4 large dimensions, no atoms. 3 large dimensions, chemistry works. Stars burn. Life evolves. The math is ruthless. And here's the thing. String theory didn't invent this constraint. Ehrenfest discovered it in 1917. String theory just inherited it. The extra dimensions must curl up, because if they didn't, nobody would be here to write equations about them. Light doesn't negotiate. So far, we've learned that string theory requires extra dimensions, that these dimensions must be compactified, and that the reason is the same Ehrenfest discovered a century ago. Large extra dimensions kill atoms. But this raises a deeper question. Is 3 dimensions where we live? Or is it all we're allowed? Here's where everything shifts. You've been asking the wrong question. The question isn't why does the universe have 3 dimensions? The question is why do observers only exist in 3 dimensions? Different question, different answer. Think about what this implies. Maybe universes with 4 dimensions exist. Maybe 5-dimensional spaces are real somewhere. Maybe every possible dimensional configuration is out there, but nobody lives there. Can't. The physics forbids observers, forbids complexity, forbids the structures that ask questions. Only in 3 dimensions do atoms hold, stars burn, brains form, curiosity emerges. People say we're lucky to live in 3 dimensions, but that's just a label. Luck has nothing to do with it. We're here because here is the only place existence permits us. Quiet. This is called anthropic reasoning. And it's controversial. Some physicists love it. Some hate it. But the math doesn't care about controversy. Ehrenfest proved it. Inverse square laws require exactly 3 dimensions for stability. More dimensions, collapse. Fewer, no complex structures. 3 isn't chosen. 3 is filtered. The only dimensional configuration that passes through the filter of allows complex observers is 3. Let me say that again. You don't live in 3 dimensions because the universe decided on 3. You live in 3 dimensions because 3 is the only number where living is permitted. The constant is enforced. This reframes everything. When you ask why is the sky blue, you expect a mechanical answer. Rayleigh scattering, wavelength, physics. When you ask why 3 dimensions, the answer is different. It's not mechanism, it's selection. 3 dimensions isn't a cause, it's a filter. And you are the proof that the filter works. Your existence, your atoms, your thoughts, your shadow on the wall. All of it is a receipt showing that 3 dimensions passed the test. Every other number failed. Beautiful. This isn't philosophy pretending to be physics. This is physics that sounds like philosophy. The universe doesn't have 3 dimensions because of some deep mechanism we haven't discovered. It has 3 dimensions because observers can only arise where atoms survive, and atoms only survive in 3. Reality doesn't issue refunds. You're not in the universe. You're in the only part of reality where you could be. That's not lucky. That's inevitable. So, why are there only 3 dimensions? Not because space chose 3, because 3 chose itself. Every other number self-destructs. collapses into chaos, dissolves into instability. 3 survives. 3 permits atoms, permits orbits, permits knots that hold, permits light that travels clean, permits you. The universe isn't generous, it's a filter, a brutal, elegant, mathematical filter, and you pass through. Do this one more time. Hold your hand up. Look at your shadow. That shadow has a crisp edge because light follows inverse square spreading, because space has exactly 3 dimensions, because the universe keeps strict books. That shadow is proof. Your shoelace staying tied is proof. Your phone finding your location is proof. You are proof. 3 dimensions isn't a fact about the universe, it's a constraint on existence itself. Ehrenfest saw it in 1917. The world ignored him. String theorists rediscovered it 60 years later, and now you know. The number 3 isn't arbitrary, it's inevitable. So here's my question for you. What else do you assume is just the way things are? What other parts of reality feel random but are actually enforced? Gravity's strength, the speed of light, the mass of an electron. Are those chosen or filtered? What else is the universe keeping strict books on? Think about it. And if this broke something in your understanding, good. That's what physics is supposed to do. Not answer questions, replace them with better ones. 3 dimensions. Not where we live, where we're allowed.